Hi everyone, in this video I will discuss how to compare orders of growth of functions using limits. So in the previous section, there are formal definitions of big O, big theta, and big omega, and you can use that to prove if one function is an element of the big O, big theta, or big omega of another function. However, this approach is quite um, quite easy for you since we can already have the proof kung part ba siya sa big O, big omega, or big theta in one approach only. So dili na ka magkuha og lain-lain pa nga constant for the big omega, big theta, and big O. So this formula limit of t of n over g of n as n approaches infinity. So, kung ang result niya is 0, pasabot ana, smaller ang order of growth sa t of n kaysa g of n. While if ang result is a constant or c constant, pasabot ana, same of order of growth silang duha. And lastly, if infinite ang result, masabutan na larger ang order of growth sa t of n than g of n. Okay, now let's review how to find the limit as x approaches infinity. So we have here on the website, since we are getting the limit of two functions and then we divide them both, so we will use these rational functions finding the limit as x approaches infinity. So let's let the numerator as p of x, then the denominator q of x, or this could be the t of n and this one is the g of n. So if you are to find the limit as x approaches infinity, we have three different scenarios. One is if the degree of our numerator is greater than the degree of the denominator, and the other is if both their degrees, the numerator and denominator, are the same, and lastly, if the numerator's degree is less than the denominators. So what is the degree? So makaingon kag unsa man ang degree, you will find the highest exponent from the function. So for this one, x cubed plus 2x minus 1, ang highest exponent is 3. So ang degree sa numerator is 3. Then this one, the denominator, ang degree niya is 2. Okay? So first scenario we have here, when the p is less than the degree of q. So meaning ang degree sa numerator daw less than sa degree sa denominator. So if ingana ang case, the limit is 0. Okay? On the other hand, if the degree of p and q are the same, meaning parehas sila og degree ang numerator of denominator, we divide the coefficients of the terms with the largest exponent. So in this case, kani nga example, ang largest exponent is 2 and the coefficient is 5 over 3. Therefore, 5 over 3 is our limit as x approaches infinity. For this one, ang highest exponent niya is 3 and the coefficient are 4 over negative 2, and that would be negative 2. So meaning, ang iyahang limit as x approaches infinity is a constant, or c, constant. And last scenario here is if the degree of P is greater than the degree of Q. Okay, so unsa may pasabot ana if ang imuhang degree sa numerator greater than the denominator. So, two possibilities ang result ana nga limit. One is the limit is positive infinity and the other one is negative infinity. So, tan-awon ra nimo na ang sign. So, balik ta ari nga example. Since kani higher man ang degree sa P kaysa Q, therefore, unsa may iyahang limit. So, ang limit niya is positive infinity. Since positive ang x cubed, positive ang x squared. Okay, so tan-awon ra ang largest exponent gihapon, then tan-awon ang signs. If dili pareho, negative infinity. If pareho, positive infinity. Okay? Another one here. Kani siya. So, ang largest exponent niya is 2. There is 1. So, since greater man ang degree sa numerator kaysa denominator, ang limit niya is infinity. Then, it is negative infinity since negative 2 o positive 5 will be negative. So, therefore, our limit is negative infinity. Okay? So, we go back here. As you realize that we have these three possibilities sad nga result, di ba? Sa gani ani. So, ani siya. Three possibilities sad. If less than ang degree sa P kaysa Q, if same or greater than. Meaning, maupod ni siya. Diba? O pariha, if pariha ang degree sa P and Q or T of N o G of N, ang iyahang result is a constant. While if less than ang degree sa T of N kaysa G of N, 0 ang result. And if greater than, infinity ang result. Okay. So, let's have another example here to illustrate. We will check what is the degree of our T of N. It's 1, while the degree of our G of N is 2. So, the degree of T of N is less than the degree of G of N. Therefore, our limit as x approaches infinity is 0. Okay? Less than. So, the degree of P or the numerator is less than the degree of denominator. So, that is 0. So, what does this implies when we talk about the orders of growth of functions in our analysis of algorithms? So, 0 implies that T of N has a smaller order of growth than G of N. So, we refer to our statement here. First two cases mean that T of N is an element of O of G of N. First two. Ang last two, tasabot nga big omega. Ang second case is big theta. So, asa man mo fall ang 0. So, diri sa first two. Therefore, our T of N is an element of, therefore, our T of N is an element of O of G of N. whereas t of n is not an element of omega of g of n, and also t of n is not an element of theta of g of n. Okay, so I hope this is clear to you. Since the result of our limit as x approaches infinity is, okay, let's have x here, x, since we are using the variable x. And this one also. Okay, so we could be consistent with our variables. So another example, our limit as n approaches infinity is 1/2. Why? Because our degree in the t of n is 1 and the degree of g of n is 1. So they are the same. So since they are the same, we will get the coefficient of the largest exponent and we divide them both. So 1 and 2. So 1 over 2, this is our limit as n approaches infinity. So since our limit as n approaches infinity is a constant, so we will use this. So this implies that t of n has the same order of growth as g of n. That means t of n is an element of big omega of g of n and big theta of g of n. Okay, the second case. And also, it is still an element of O of g of n. Okay, so you can say here, therefore, t of n is an element of g of n. Also, t of n is an element of g of n, and t of n is also an element of O of g of n. Okay, now let's have one last example. P of n t of n equals two n cubed plus 3, while our g of n equals 3n minus 1. Okay, so we will find the limit as n approaches infinity. Okay, we have 2n cubed plus 3 and 3n minus 1. So in this case, our degree in the t of n is 3, while the degree of g of n is 1. So what will be our limit? So our limit will be infinity. And let's take a look at the largest exponent in our t of n and g of n. This one is 2. So positive 2, and this one is positive. So we have positive infinity. Okay, so we refer here, since it is infinity, this implies that T of n has a larger order of growth than G of n. So, meaning, ang atoang T of n is an element of big last two. Okay, that's right. The last two mean. Okay, so this is the only one that fits the infinity, ang last two. So, T of n is an element of big omega of G of n. Okay, so I think that would be all for this one. And you need to master how to find the limit so that you can try the easier ones in finding the orders of growth of functions. Thank you.